Good afternoon, everyone. So, in today's class, in yesterday's class, we have studied about the kernel of homomorphism and the theorems of kernel of homomorphism. In today's class, we shall study about fundamental theorems of homomorphism. Okay. What is today's class is on? 1 second. Today's class is on fundamental theorem of homomorphism. Okay. Fundamental theorem. Fundamental theorem of homomorphism. Okay. Let's get the fundamental theorem of homomorphism. So, what does the statement says for this? So, statement if f dot f colon g tends to g bar is a homomorphism with kernel K then f of g is isomorphic to the quotient group G by K. Okay. This is your statement overall. Okay. So what does statement says? So if G is mapping to same, here also the same conditions apply. This is a G and this is a G bar. We mapping here with F. Okay. So G, if F colon G tends to G bar, hence G is mapping with G bar. They are saying is a homomorphism with kernel K. It is homomorphism with kernel K. Then f of g is isomorphic to the quotient group G by K. By using this, we have to prove that f of g is a isomorphic of quotient of group G by K. This is a proof. Okay. So next proof. Okay. Next proof. Proof the given data. If first we will write the given data are f colon g tends to g bar is a homomorphism tends to range f in range entry will range kottavanu. Okay. F that is f of g is a subgroup G bar. So next, given data f of G is a group. Is a group. Okay. F of G is a group. Next, defined by the mapping. So in first the given data is for us is F colon G tends to G bar. Here G is mapping within G bar is an homomorphism. It is in the form of given data. So given data only first three steps. The given data first step. The given data first step is F tends to G tends to G bar. Next the range in the F, that is of F of G is a subgroup of G bar. G in F of G in G bar. Next, F of G is a group. Or obviously we know that the quotient of a group is in F of G is in group. We got the quotient of a group on that. So next, in the next page, now defining the mapping. Defining the new mapping. Phi colon G by K tends to G bar. F of G. Since K is a, you already know that K is a creep or if K is a normal. K is normal. By the definition of K is normal, by the definition of kernel of homomorphism. So by next phi of Ka is equal to F of A. This is not W F of W or F of A or F of A for all Ka is equal to Ka belongs to G by N. G by K. G by N is a normal subgroup of, but it should be a K. In the given question, it is a K. G by K. That is for all A belongs to G. This is equation number 1. To show that phi is a isomorphic. Phi is an isomorphism. Phi is an isomorphism. So what we shall prove? Phi is an homomorphism first into. Phi is an homomorphism prove madade. Next second point another. Phi is 1 to 1. And third point is phi is on. So phi to phi very out terms to consider. We established here now we consider here. So in the first phi of 203 phi colon G by K that tends to F of G. F of G K is a normal. Therefore, phi of K is kernel of homomorphism. Kernel of homomorphism phi of Ka. So phi of Ka is equal to F of A because F of phi is tending to G by K. G by K is tending to F of G. So we can write this. So we can write this as like this. Okay. So each other phi of Ka is equal to F of A for all Ka is equal to A that belongs to G by K. That belongs to G by K order. You have to turn into concept same other. Therefore, we can write A belongs to K. Phi of Ka is equal to F of A. Concept same other. We can write that phi of Ka is equal to f of a. Therefore, to show that phi is a homomorphism prove ಮಾಡಾದಂದ್ರ so that means that phi sorry phi is an isomorphism prove ಮಾಡಾಯ್ತಂದ್ರ first ಏನು ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು phi is homomorphism prove ಮಾಡ್ಕೋತೀವಿ phi is 1 to 1 ಅನ್ಬೇಕು phi is ontogamy ನಮಗೆ isomorphism prove ಮಾಡಾಯ್ತಂದ್ರ ಇವು ಮೂರು ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆದಾಗ ನಾವು ಓಕೆ ಈ ಮೂರು ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆದಾಗ ನಾವು ಇದನ್ನ ಐಸೋಮಾರ್ಫಿಸಮ್ ಅಂತ ಹೇಳ್ಬೋದು ಸೊ ಫಸ್ಟ್ ಕಂಡೀಷನ್ ಅದು phi is homomorphism prove ಮಾಡ್ತೀವಿ ನಾವು phi is 1 to 1 ಮಾಡ್ತೀವಿ and phi is onto ಮಾಡ್ತೀವಿ ಇವು ಮೂರು ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆದಾಗ ಇವು ಮೂರು ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆದಾಗ we can say that it is an isomorphism so ಇಲ್ಲಿ ಸಹ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗಿದೆ so next page ಅಲ್ಲಿ ಹೇಳ್ತೀನಿ so next we shall start with the first step ಏನು ನಮ್ದು first ಏನು ಪ್ರೂವ್ ಮಾಡಬೇಕು ಅಂತ ಅನ್ಕೊಂಡಿದ್ದೇವೆ ನಾವು phi is to prove that phi is homomorphism phi is homomorphism so phi is homomorphism ಅಂದ್ರೆ first ನಮ್ಮ ka kb belongs to g by k considering now we consider phi of ka into kb is equal to phi of kaab okay so ಇದು ಹೇಗಂದ್ರೆ by the definition of product cosec ನೋಡಿ ಇದು cosets ಓದಿರಲ್ಲ cosets ಅಲ್ಲಿ product of cosecants ಬರ್ತದ so properties of cosets ನ ಓದಿರ್ನಿ ಇದು product of cosets ಅಂತ ಹೇಳಿ so okay so in previous question ನಮಗೆ ಏನಾಗಿತ್ತು ಒಂದು ಸೆಕೆಂಡ್ ಓಪನ್ ಮಾಡೋಣ so ka is equal to ka for that belongs to g by k that is for all a belongs to g so as usually next a b ತಗೊಂಡ್ರು as usually ಇಲ್ಲಿ ನೋಡ್ರಿ a b ಬರ್ಕೊಂಡಿದ್ದಿಲ್ಲ ಅಂದ್ರೂ so KAB is equal to KAB ಮಾಡ್ಕೊತಾರೆ that belongs to G by K ಆಗ್ತದೆ so that belongs to A, B belongs to G so ಅದೇ ಆಗ್ತದೆ ಇಲ್ಲಿ so ಅದಕ್ಕೆ ಇಲ್ಲಿ ನಾವು next step product apply ಮಾಡುತ್ತೆ ನಾವು product apply ಮಾಡೋದಕ್ಕೆ KA into KB ತಗೊಂಡು phi of KA is equal to phi of KB by the product we can write this as by combining okay so next this phi can be written as f of AB ಇದು f of AB ಹೆಂಗ್ ಬರುತ್ತೆ ಅಂದ್ರೆ by the definition of phi so first in equation number 1 so in equation number 1 ಅಲ್ಲಿ ಪ್ರೂವ್ ಮಾಡಿದ್ದೇವೆ ನೋಡಿ ಇದು equation number 1 ಅಲ್ಲಿ ತೆಗೆದು equation number 1 ಓಪನ್ ಮಾಡೋಣ ಸೆಕೆಂಡ್ ಮಾಡಿ equation number 1 page number 2 ನಲ್ಲಿ so equation number 1 okay phi of ka is equal to f of a ಇದು ಯಾಕೆ ತೊಗೊಂಡಿದೆ ಅಂದ್ರೆ these concepts ಇವು ಎರಡು ಕಾನ್ಸೆಪ್ಟ್ ಸೇಮ್ ಆಗ್ತಾವ ನಮಗೆ ಹೌದಾ ಇವೆರಡು ಕಾನ್ಸೆಪ್ಟ್ equal to ಏನು f of g so we can write ka is equal to ka belongs to g by k ಇದ್ದಾಗ ನಾವು ಏನು ಬರ್ತೀವಿ f of a ಬರಿಬಹುದು therefore ಇಲ್ಲಿ ನೋಡ್ರಿ ಈಗ ಏನು ಬರ್ತೀವಿ ಅಂದ್ರೆ so ನಮಗೆ ಏನು phi of kab ಅದ f of a into b ಬರಿತೀವಿ ನಾವು f of ab ಬರಿತೀವಿ so this f of kab can be written as splitted f of a into f of b by ಇದು ಹೆಂಗ್ ಮಾಡ್ಕೊಂಡು ಇದು ಹೆಂಗ್ ಬರ್ತಂದ್ರೆ f is homomorphism definition ನೋಡೋದಲ್ರಿ f of a into b ಹಿಂಗ ನೋಡ್ರಿ f of a b into b is equal to f of a into f of b ಅಂತಿದೆ so ಈ ಫಾರ್ಮುಲಾ ನೆನಪಾರ್ದ್ರೆ homomorphism isomorphism ಪೂರ ನೆನಪಾರ್ದಂಗೆ ಈ ಫಾರ್ಮುಲಾ homomorphism isomorphism ಇಲ್ಲಿ ಎಲ್ಲಿ ತನಕ ಎಂಡ್ ಆಗುತ್ತೆ ಅಲ್ಲಿ ತನಕ ನೆನಪಿರಲೇಬೇಕು ಓಕೆ so next therefore we can write that phi of ka into kb is equal to phi of ka into phi of kb this is by equation number 1 so idu by equation number 1 so now phi is a homomorphism ante prove ಮಾಡಿದೆ ನಾವು okay phi is a homomorphism okay phi is an homomorphism hang ಬಂತು ಸರ್ ಎಲ್ಲ ಇದು equation type ನಮಗೆ homomorphism ಹೇಳಲ್ರಿ so ಇದು homomorphism equation ಅಂದ್ರೆ f of a into b is equal to f of a into f of b so ಈ ಫಾರ್ಮ್ ಆಫ್ equation ಆಗಲ್ಲ ಇದು so ಈ ಫಾರ್ಮ್ ಆಫ್ equation ಇದ್ದಲ್ಲಿ ಅದಕ್ಕೆ ಏನಂತೀವಿ phi is an homomorphics ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಪ್ರೂವ್ ಆಯ್ತ್ರಿ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಪ್ರೂವ್ ಆಯ್ತಾ ನಮ್ದು ಸೊ ಇದು ಪ್ರೂವ್ ಆಯ್ತಾ ನಮಗೆ ಹೌದಾ ನೋಡ್ರಿ ಇದು ಒಂದು ಸ್ಟೆಪ್ ನಮಗೆ ಪ್ರೂವ್ ಆಯ್ತು ಸೊ ಆಸ್ ಯೂಶುವಲಿ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ಹೋಗ್ತೀವಿ ಸೊ ವಾಟ್ ಇಸ್ ಸೊ ಇಲ್ಲಿ ಸೆಕೆಂಡ್ ಫಸ್ಟ್ ಪ್ರೂವ್ ಆಯ್ತು ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಪ್ರೂವ್ ಆಯ್ತು ಸೊ ಇಲ್ಲಿ ಗೋ ಫಾರ್ ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ ಸೊ ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ ಏನಾಗ್ತದೆ ನೋಡ್ರಿ ಸೊ ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ ಏನಾಗ್ತದ ಟು prove that phi is 1 to 1 phi is 1 to 1 for all ka comma kb belongs to g by k considering phi of ka is equal to phi of kb ka is phi of kb ಅಂತ ಹೇಳಿ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ ಓಕೆನಾ ಸೊ ಕನ್ಸಿಡರ್ ಮಾಡೋಣ ಸೊ ನೆಕ್ಸ್ಟ್ ನೋಡಿ it implies f of a is equal to f of b so phi of ka is equal to phi of kb ಬರ್ಕೊಂಡಿದ್ದು it is obviously we can say that f of a is equal to f of b in previous proof in one first proof we have seen that kf of k we can be written as f of a okay as well now post multiplying ನೋಡಿ post multiplying ಏನು ಮಾಡ್ತೀವಿ ಅಂತ ನೋಡಿ post multiplication so post multiplication ಏನು ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ f of b whole inverse ನಾವು f of b inverse ನಾವು post multiply ಮಾಡ್ತೀವಿ so post multiply ಏನು ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳಿ ಫಸ್ಟ್ f of a ಅಷ್ಟೇ ಬರ್ಕೋರಿ f of a ಆದ್ಮೇಲೆ ನಾವು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ ಅಂದ್ರೆ post multiply f of a ಗಿಂತ ಹೆಂಗ್ ಮಲ್ಟಿಪ್ಲೈ ಅಂದ್ರೆ ಪ್ರೀ ಮಲ್ಟಿಪ್ಲೈ into f of b whole inverse is equal to f of b into f of b whole inverse ಅದ this is post multiply so post multiply ಮಾಡಿದ್ಮೇಲೆ f of b into f of b into f of b whole inverse ಏನಾಗ್ತದೆ ಅಲ್ಲಿ ನಿಮಗೆ e ಆಗುತ್ತೆ so as usually ಸರ್ e ಬಾರ್ ಆಗುತ್ತೆ e ಬಾರ್ so next you have terms combine again f of ab inverse is equal to e bar okay so as usually remaining by the definition of next by definition of kernels capital K ಬರೀತೀನಿ ಪೂರಾ kernels ಬರಲಿಕ್ಕಾಗಲ್ಲ so space is not I don't have space here so by the definition of kernels we remove this f and f bar of this f and f bar ab inverse belongs to capital K ab inverse belongs to capital K therefore ae belongs to kb ae inverse is equal to kb next page I will explain this a is equal to ae belongs to kb a belongs to kb but a belongs to ka okay so as implies ka is a subset of kb similarly it can be kb is a subset of ka therefore ka is equal to therefore ka is equal to kb therefore ka is equal to kb here ka is equal to kb that is phi of ka is equal to phi of kb that implies ka is equal to kb for all ka comma kb belongs to G by K. This is phi is 1 to 1 mapping. Okay, so I will be explaining now. So in new page 4, so what we have considered to prove that phi is 1 to 1. So phi for all Ka Kb belongs to G by K. So in prove madadanga phi is 1 to 1 prove madada. So adike ಏನು ನೋಡ್ತೀವಿ Ka, Kb belongs to G by K consider ಮಾಡ್ತೀವಿ. So what we consider Ka is equal to Kb ಅಂತ consider ಮಾಡ್ತೀವಿ. ಹೋಲ್ಸಲ ಏನಾಯ್ತು Ka ಒಂದೇ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿದ್ದೇವೆ ಅದರ ಕಡೆಯಿಂದ Ka Kb ಮತ್ತೆ ಆಮೇಲೆ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿದ್ದೇವೆ. So ಇಲ್ಲಿ phi of Ka is equal to phi of Kb consider ಮಾಡ್ಕೊಳ್ತೀವಿ. So this phi of Ka is equal to phi of Kb can be written as phi of A into phi of A is f of A is equal to f of B. So you already I have said in previous proof 1 I have said how we will shall write f of phi of Ka is equal to phi of Kb. So we have written here f of A is equal to f of B. So now next here this I have introduced here this post multiplication of f of B whole inverse. So we wrote f of A as it is, now multiplying by f of B in f of B whole inverse next is equal to as it is f of B as it is here. Afterwards f of B into f of B whole inverse we have multiplied here post. So the value of f of B into f of B whole inverse is E bar. So next these two multiplication f of AB inverse is equal to E bar. So now by the definition of kernel homomorphism, the kernel of homomorphism by using kernel of homomorphism we can say that AB inverse belongs to K, therefore AE belongs to KB, A belongs to KB, A belongs to KB, but A belongs to KA also. So your two terms belong to A. So A KB no belong to A KA no belong to. Therefore we can write KA is a subset of KB. Similar KB is also subset of KA. Therefore you have to subset KA or KB subset is KB ka KA subset is we can write that KA is equal to KB. Therefore phi of KA is equal to phi of KB. That implies KA is equal to KB for all KA KB belongs to G by K. Therefore this is equal to this either you have to subset either subset idu. So I am noting KA is a subset of KB and baritive. So as usually either subset either subsetting ulta aitandra we can say that this is phi is 1 to 1 mapping anta helbodu. Okay, so as usually so next proof of this is last proof. The third proof to prove that phi is onto. To prove that phi is onto. Phi is onto since f of G is a range. F of G is a range. Each of its elements must appear each of its appear as an image of some elements of G under F. Therefore phi of B belongs to f of G that is it exists some A belongs to G such that B is equal to f of A. Further we know that for each A belongs to G that exists Ka in G by K, G by K, thus for all B belongs to f of G that exists some Ka belongs to G, Ka belongs to G by K such that once again wait for such that phi of KB is equal to phi of Ka is equal to f of A is equal to B. Okay, so here what we have to do? Prove that phi is an onto ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. Okay, phi is an onto ಅಂತ ಪ್ರೂವ್ ಮಾಡೋದಾ? Since f of G ಅಂದ್ರೆ ಒಂದು ರೇಂಜ್ ಅದ. So if I say this from f of G from G to G bar means this is a range, means 1 to 10 means ಇದ್ರ ಒಳಗೆ ಇರುತ್ತಲ್ಲ range ಅಂತ. So each element must be appeared an image of such some elements under a G of F. So now G ನಿಂತ G ಬಾರಿಗೆ ಮ್ಯಾಪ್ ಮಾಡ್ಲತ್ತೀವಿ. ಓಕೆ, ಸೊ ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಹಿಯರ್. G into G ಬಾರಿಗೆ ಮ್ಯಾಪ್ ಮಾಡ್ತೀವಿ. ಇದು ಇಮೇಜ್ ಆಗ್ತದ. This is image, this is pre-image. This image this is image. ಇದು image ಆಗುತ್ತೆ, ಇದು pre-image ಆಗುತ್ತೆ. ಓಕೆನಾ? ಸೊ ಇಲ್ಲಿ ಟರ್ಮ್ ಅಲ್ಲಿ ಕಾಣಿಸ್ಬೇಕು ನೋಡಿ, ಇಲ್ಲಿ ಟರ್ಮ್ ಅಲ್ಲಿ ಕಾಣಿಸ್ಬೇಕು, ಇಲ್ಲಿ ಟರ್ಮ್. ಸೊ ಇಲ್ಲಿ f of G ಇತ್ತಂದ್ರೆ ಇಲ್ಲಿ x ಸ್ಕ್ವೇರ್ ಇತ್ತಂದ್ರೆ 2x ಆಗುತ್ತೆ, ಹೌದಾ? ಸೊ ಇಲ್ಲ ಆಸ್ ಯೂಶುವಲಿ ಇಲ್ಲಿ 3x ಸ್ಕ್ವೇರ್ ಇತ್ತಂದ್ರೆ ಸೊ ಇಲ್ಲಿ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಆಗಿ ಇಲ್ಲಿ ಇರಬೇಕು. ಸೊ ಆಸ್ ಯೂಶುವಲಿ ನೆಕ್ಸ್ಟ್ ಏನಾದ್ರು ಕನ್ಸಿಡರ್ ಮಾಡಿ ಸೈನ್ ಇತ್ತಂದ್ರೆ ಇಲ್ಲಿ cos ಆಗಬೇಕು. ಸೊ ಆಸ್ ಯೂಶುವಲಿ ಇಮೇಜ್ ಇದ್ದಿದ್ದು some part of image some under should be pre-image ನು ಆಗಿರಬೇಕು. ಈ pre-image ನು f is a under pre-image ಅಂತ ಬರೆಯಬಹುದು. Therefore that is for all B belongs to f of G there exists sum of A belongs to G such that B is equal to f of A. So for all B belongs to f of G then so all B belongs to f of G, therefore A also belongs to G. So such that we can write that B is equal to f of A. Further we know that every part of A belongs to G, therefore we can also write Ka in G by K. So Ka no G by K na. So every part of G tandra we can say that Ka in G by A. So thus obviously, so next thus for all B belongs to f of G. So A no belongs to G ಆಗಿರ್ತದೆ. As usually B belongs to f of G ಇರ್ತದೆ. So we can write that f of Ka belongs to G by K such that next time there Ka belongs to G by K, therefore phi of Ka is equal to fa, that is fi is equal to B ಅಂತ ಹೇಳಿ ಪ್ರೂವ್ ಮಾಡಬಹುದು. ಸೊ ಇದು ಪ್ರೂವ್ ಮಾಡೋಣ ಏನು ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ each element of f of G appears as an image of some elements of G by K under phi. Thus phi is onto mapping. Hence we can say that phi colon G by K that implies f of G is an isomorphic. So G by K is that directly implies to f of G. So as usually f of G is an isomorphic image of G by K. Okay, so phi of ka is equal to f of a and f of a is equal to ba. Therefore each element of f of g appears as an image. So f of g na idu image anta nastori number. Okay, so g f of g ಅಂತ ಹೇಳಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ಳಿ. f of g ಅಂತ ಹೇಳಿದ್ರೆ ನಮಗೆ ಇಮೇಜ್ ಅಂತ ಕಾಣಿಸ್ತದೆ. ಸೊ ಇದು ಇಮೇಜ್ ಅಂತ ಕಾಣಿಸ್ತದೆ, ಇದು ಏನಾಗಬೇಕು, ಪ್ರೀ ಇಮೇಜ್ ಆಗಬೇಕು. ದಿಸ್ ಇಸ್ ಪ್ರೀ ಇಮೇಜ್. ಸೊ ಪ್ರೀ ಇಮೇಜ್, ಇದನ್ನ ಪ್ರೀ ಇಮೇಜ್ ಅಂತ ಹೇಳಿ ಕರೀಬಹುದು. f of g ನ ಇಮೇಜ್ ಅಂತ ಕರೀರಿ, g ಅನ್ನ ಪ್ರೀ ಇಮೇಜ್ ಅಂತ ಕರೀರಿ. ಸೊ the each element of f of g means image as an image of and some element of g by k. Idan some element of g by k under phi irtave ಇಲ್ಲಿ ಎಲಿಮೆಂಟ್ಸ್ phi ನಾಗ ಇರ್ತಾವೆ. ಓಕೆ, ಸೊ thus phi is onto ಇಲ್ಲಿ one link double process ಆಯ್ತಂದ್ರ onto function ಅಂತ ಹೇಳ್ಬೋದು. Therefore phi colon g by k tends to f of g. So g by k or g ಅನ್ನ g by k ಅಂತ ತಗೊಂಡು ಇದು f of g ಅನ್ನು ಯೂಸ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಇದರಿಂದ ಇದು ಮ್ಯಾಪಿಂಗ್ ಆಗ್ತದೆ. ಸೊ g by k, so g by k is obviously equals to f of g. Therefore f of g is an isomorphic. So f of g isomorphic ಯಾಕಂದ್ರೆ ಮೂರು ಕಂಡೀಷನ್ ನಮಗೆ ಸ್ಯಾಟಿಸ್ಫೈ ಆದವ್ರಿ. ಮೂರು ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗೋಣ ಅಂತ ಹೇಳಿದ್ರೆ ಐಸೋಮಾರ್ಫಿಸಮ್. ಸೊ ಫಸ್ಟ್ ಕಂಡೀಷನ್ ಈಸ್ ಹೋಮೋಮಾರ್ಫಿಸಮ್ ಆಗಬೇಕು, ಆಮೇಲೆ 1 to 1 ಆಗಬೇಕು, ಆನ್ ಟು ಫಂಕ್ಷನ್ ಆಗಬೇಕು. ಆನ್ ಟು ಫಂಕ್ಷನ್ ಆದಾಗೆ ಅದಕ್ಕೆ ನಾವು ಆನ್ ಟು ಫಂಕ್ಷನ್ ಆದಾದ್ಮೇಲೆ so we can call f of g is an isomorphism. Okay.